to 10, and which is what is happening over here. Understanding my point?
Yes, sir.
Now, the only thing you need to keep in mind, or you have to take care of, is that whenever you are converting, let's say any number is given in R equal to 2, 1 triple 0 double 1, 00 triple 1, 0. When you start converting it to R equal to 8, what you have to keep in mind that always start from the least significant bit. So start clubbing from here. So these 12 bits, what you are having, can be represented as 4 bits in the R equal to 8 system. So you can have something like 4316 in this base value. So this is one way to represent the numbers in a compact manner. There are many other ways, so we will come to that also. Fine. So this is clear.
Sir, in base 8, we call it bit only.
You can call bit, you can call digit, you can call byte, whatever suits you. But yeah, different combinations. No, people are giving names to different terms, so that's okay. It doesn't really matter much as long as you remember that what you are referring to. So in general, you can call it digit itself. That is universally accepted unless it is for R equal to 2. Only for R equal to 2, the bit is the correct way of saying. So sometimes this is called octal. So instead of digit or bit, is this one octal number, or how many octal places are there? Okay, that is another way of saying. Correct? Yes or no?
Yes, sir.
Yeah, suddenly the class goes down. I don't know what happened. Moving to another class. Clear? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now
Yes, sir.
let's say we have, see this 12 bits you can have no division by 3 and you can have very comfortably. But as we had the previous one, only some 8 bits were there. So 1 bit shortage was there when you were converting this 10110011, this 179. So one shortage is there when you are clubbing this all together in pairs of or in groups of 3. So always we can add something on the most significant bit side. We can add 0 over here, but we can never add any 0 on the least significant bit side.
It will change the value.
Yes, this is what I'm trying to indicate. For example, with a simple number, I can show you this thing. Let's say a simple number 00 is there, or maybe 2 bits are there, not 00, and the number represented is something like 10, let us say, and you want to convert it to octal system. So obviously you have the options to add one extra bit. Now if you add, go by 2 options, one adding like 100 and another thing adding like 010. These are the 2 options, right? Yes or no? Say
Yes,
something.
sir.
Okay.
Yes,
So do you
yes.
see the difference in the values what it has made?
The
What
adding
is
on the right has shifted the place,
ah,
increased the
yes,
power.
yes. So this term what you have used, right hand shift, left hand shift, these things we will use for our other arithmetic operations. So if here, when we are keeping things simple and doing simple things, as of now, we have the liberty to add anything on the most significant bit side. Adding anything means 0, not 1. We can only add 0, but we can never have this. Clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, some of you might have taken all these things in your other previous courses or maybe sometimes in 12th standard, but those who have not taken, I want to clarify it to them very well. So you have to respond. Some of you might be knowing this, even little bit more things in this. So that is fine, it's okay. Fine. So then we will go to our next higher radix system, which is even more commonly used, which is the hexadecimal number system. Where we are clubbing 4 bits together and we are making one number. So of course here our base is 16. So we will discuss more on this thing tomorrow during our lab time. So there is announcement regarding the lab that tomorrow onwards our lab session would go on routine. So Wednesday 4 to 6 p.m. what we have kept, and we will have alternate days for having the lab exercise and the lecture. So on one Wednesday we will have lecture, next Wednesday we will have lab exercise. Clear? So tomorrow I will start with the lecture 4 to 6, and from 18th we are going to have our first lab exercise. So about this also I will brief you little bit what experiment you have to do, how you have to do. But one thing I would say which you have to be prepared with is installing MATLAB in your system. If you don't have system, then you have to manage it somehow. Let's say borrow it from someone, or take help of some other friend or some other, if some batchmate is nearby. So you can do all those things, but you have to be prepared with MATLAB. We'll be doing our exercises on Simulink. So little bit you need to be familiar. More things we will do during the course itself. So from 18th you will have the first lab exercise, but anyway the lab session would go on as it is in the routine. So we will have lecture tomorrow during our lab session. Clear?
Yes, sir.
Okay.
Yes, sir.
Okay, little bit more enthusiastic. Yes, I would need from next time onwards. So I'll stop the class over here. If you have any doubts, you may ask. Then otherwise we can stop.
Sir, while